So we always do this build up. So we start from the core, then we talk about all the components around, and then we have more strategic view. I would like to tell you what happened in the past year. I repeat the same timeline that Frederick showed, going a bit back to the release of version 3 to highlight that last year there was a lot happening. There was a storm of new features and updates to version 3. And since then, you might have noticed that we only had the one now scheduled release. So this looks a bit like the peace after the storm, but this also means that things are now getting polished on the new version and things are working, and we are focusing on the next things. I would like to remind you that when we talk about the ecosystem, we talk about the core library plus all the bindings, plus the adapters, plus tutorials, documentation, infrastructure around it. And for the components that are in a good enough state that we consider publishable, we bundle everything together in something we call the preCICE distribution. And we make a data publication out of this. So this is something that also has a DOI, as you can see at the bottom. And we made the last release after updating everything to version 3. This is something you can cite for reproducibility if you have not changed something in the codes, or you can say based on that with those changes. And it also has another nice use case. It tells you that these things of these versions work nicely together, because you realize that as we update, for example, the core library, if you are using an adapter that is not yet updated to support the latest features, maybe it's not fully yet making use of the potential at least. Some numbers about the ecosystem and focusing on what is on our maintenance side and on the lists we maintain on the website. We have bindings for 7 programming languages. I think you all know them. Then we have 8 adapters currently in the distribution and 32 on the website. This is 2 new compared to last year. I will come to the additions in the next slide. 33 different tutorials, 1 new. Out of this, because this tutorial has different options for solvers, these are 109 solver cases at the moment. And on the preCICE organization on GitHub, we have 64 repositories. What I want to tell you also out of this is that things are getting a bit out of hand for the team size we have. And that's where we really rely on the community also stepping up and helping us with the maintenance. I will say a bit more about this later. In terms of the new additions, we have the Gizmo adapter, currently maintained by Xingya Li, who has a poster this year, and there is a recording of her talk last year on YouTube. And we also list now the ISSM adapter. We will have a related talk by Thomas Kleiner tomorrow. Then, in terms of tutorials, the one new tutorial we have is a variant of the already known perpendicular flap fluid structure interaction tutorial that exchanges stresses instead of forces. And there we use fluid again for the open foam, but Gizmo for the solid. And if you say that for your solid solver this exchanging stresses makes more sense, you can now also just go there and add your structure solver as an option. There are a few new repositories. For one of them is the CLI, a command line interface for the various tools. The profiling that you already used in a previous version in the course. 3 tools to check, format the configuration file, and create a graph out of it that other tools are using. And we now have a repository where we are working on a generator for precise cases. There will be a talk tomorrow by Felix Neubauer about this. And we also have 2 new repositories related to the OpenFOAM adapter. These are both forks, and I will talk about them in a moment. I wanted to remind you that there is this list of adapters on the website, and there you are highly encouraged to list your adapter if it's also meant to be used or continued by other people. And these are the 2 that I just mentioned. The Gizmo adapter so far does the structure part in fluid structure interaction simulations. From what we heard earlier today, this is developing towards fluids as well. This is an isogeometric analysis code. And the ISSM that comes from the glaciology and models the ice sheet and sea level interaction. Then a ghost from the past that every now and then wakes up is the fluid adapter. This is to remind you that there is an adapter. I'm not aware of many people using it at the moment, but we need users to have motivation and feedback when developing it. This is now updated to preCICE version 3 as part of a student project, and you can read the respective thesis also on the link. And the idea is that, yes, it works now. If you want to pick it up, let us know, especially now before the knowledge really diffuses again. Regarding the Phoenix X adapter, there will be a poster by Niklas Vinichenko tomorrow. The main message here is, again, that this is active. In terms of other adapters, the updates are mostly maintenance related. Something that I picked up that I really liked was that people not only use but also try to contribute to some of them. For example, the Calculix adapter. Someone, while trying to debug the problem they were facing in the forum, they wrote everything they had tried, and in the end they said, I found a bug, something was missing from the implementation. And then I said, okay, that's nice, I can confirm it, we patch it. And even if you find such issues but you are not comfortable contributing directly on GitHub, this is also a way of giving back. Other interesting things is that from the next release of the adapter, you will not need to install YAML CPP separately. This is now a header-only dependency. And talk to Ishan Desai if you're interested in volume coupling with the Calculix adapter. He had a nice project with NASA Glenn, trying to use Calculix coupled with micro simulations in material science. Then I can talk a bit more about the OpenFOAM adapter that I maintain. And as a first slide, I wanted to draw your attention to a very recent addition, not actually to the adapter, but of the adapter to something else that is very new. I mentioned in my user introduction talk that I organized the RSE group in OpenFOAM, and through that came in touch with Gabriel Guerlero and Gregor Olenik, who also developed a new variant of OpenFOAM from scratch, made for more modern environments. And as part of that, they are developing the Styro package manager. This is specific for OpenFOAM, similar to pip for Python, for example. You can now say Styro install and an OpenFOAM package. And now the OpenFOAM adapter is part of that, which is a badge of honor for us. This is one of the first packages they have added. And if you are developing something related to OpenFOAM, maybe you want to add it there as well, to the OpenFOAM package index. Other news, things that are already on the develop branch and you can use, and we plan to make at least a bug fix release after the workshop. There was, since long, a strange issue that appeared whenever you run implicit coupling simulations with some turbulence models. This is now fixed due to work mostly of Daniel's. And then we realized that you could not make a unidirectional coupling with the OpenFOAM adapter just because of a very simple technical reason that we now raised. So now the read data and the write data are now optional. And something that is mostly important from the developer side is that before, since we are using the function object interface of OpenFOAM, we needed to hack around the error handling of OpenFOAM to let us really trigger an error when something went wrong in the initialization. This is now not needed anymore. We removed a lot of these hacks, since recent OpenFOAM versions allow the user to specify that an error in a function object is really an error. And to enable that, you can just go to your control dict and say that I want my error checking to be strict. The bigger issue that Daniel and me are currently working on is enabling FSI simulations with implicit coupling with subcycling. The only reason that this doesn't work at the moment is technical, but it is also very complicated technically. We are very happy to talk individually with anyone that is interested in that later. And picking up on what I said before, that we really need the community to help us maintain all this zoo that we have now adopted or started. We are trying to make supporting different OpenFOAM versions easier. A couple of years ago, up to the preCICE version 2 times, I was maintaining the adapter for multiple OpenFOAM versions, including the OpenCFD and the Open Foundation versions. And this is getting more and more difficult to keep track of, especially since this is not our main interest if one version is working easily. Still, the community, our community, works with different OpenFOAM variants. and we want to enable that in a more democratic way. As a first step, we have now 2 forks of the original adapter on our GitHub organization. The one is for the OpenFOAM Foundation variant. The other variant is for Foam Extend. For the Foam Extend, there was interest, and there is already active contribution by Patrick Hun, who also has a poster about this. And for the Foundation variant, I have already ported some of the older versions, and I'm looking for interest and help to port the rest and pass them over to another maintainer. As a message here is that the community contribution here would be essential if we were to keep maintaining all of these different options. Some further news. There is since longer an experimental Elmer adapter. This was previous work by Benjamin Rodenberg, student of him, Ishan. And now it was very nice that the community is picking this up. There was already one of the first contributions. I have no idea who the person is, just found us on the internet. He's writing a lot in the forum, whoever you are, thank you. And next point would be the Dumux adapter. So Dumux is a code for porous media applications, actively developed also at the University of Stuttgart. Mattis Kelm is currently working a lot on that, and he's also working on the adapter. And for the micromanager, I will skip all the duplication and refer to the poster of Ishan. Coming up, adapters that are not yet public in our organization, but will soon be. Results of work of David Schneider, Robin Waruner, student of David, and Anthony Thornton. Adapters for particle code, for the particle codes, lights, and Mercury DPM. In terms of tutorials, there is one interesting new case. So we had already the channel transport. This is a channel, and you initialize somewhere a blob of some quantity, and then this is transported over the domain. Frederick needed a use case for the feature of remeshing, and he added a variant of that case that uses adaptive mesh refinement, and as you see here, refines the interface around the refines the mesh around the sharp interfaces of the quantities, and this then is a nice use case that we now also host on our website. Other news, and you can also see on the right the major people behind them. We have the perpendicular flap with Gizmo. We have Nutils options for the Turechron FSI3 benchmark. This comes directly from one of the Nutils maintainers. Then we have Fortran variants for the 1D elastic tube tutorial. Someone already was asking about Fortran earlier today. This comes from a student in one of our courses in Stuttgart. We had more improvements in our RSU2-based tutorials. This comes by Josef Signorelli. He's a PhD student in the group of Daniel Bodoni that will be our keynote speaker tomorrow. And then, we have under review some pull requests. We are getting a partitioned heat conduction tutorial with Gizmo, a Julia participant, a Julia option for the resonant circuit tutorial, an example of the foam extend adapter with for the perpendicular flap. And we are reviving with a student of mine an older published tutorial that is a 1D 3D coupling of fluids on a scenario that is known as the water hammer. And another use case that Frederick is now building for the remeshing feature is the growing mesh case. In terms of the website, things you might notice, and all of these are links, and maybe would be a good opportunity to show them around. First of all, I wanted to point your attention to the fact that we have a literature guide. This is something that helps you, for example, start reading about specific features. How does the quasi-Newton, for example, work? What academic publications should I read about mapping, and so on. This now has more content, and also has a list of the currently completed PhD dissertations, now including Benny. Then, if I find my slides again, we have quite rewritten performance analysis documentation. So this you find under tooling, where you can also find about the config visualizer, the FMI runner, and so on. We have a page that you might already have visited as part of the course today on how to run preCICE on clusters using SLARM, and what you might need to pay special attention to there. The release schedule that Frederick just talked about is publicly documented. This is in the part of the documentation that is more directed towards developers. We also have here a page about our publication strategy. Then two additions that are coming up is more documentation on how to restart Calculix-based simulations. There we need some feedback. So if you're experienced with that, please let me know. And as part of work of another student, we will soon get content from the forum rendered on the website, including frequently asked questions. Something that might be interesting if you are coming to talk in one of these workshops or sessions we organize in other conferences is guidelines about how to talk about your work. This you find under contribute. We have also these pages that Benjamin is going to talk about in a moment. And if you like what we are doing as a workshop, you can now also find out how we organize it and how you can organize such a workshop for your code. We have taken the documentation and open perspective also in this aspect. And finally, something that might be interesting for you to check is that our website analytics is also based on an open source tool. It's linked under About. Everybody can see it, and it's also cookie free, and you can see, for example, where our users are most likely distributed. Another example is that our step-by-step guide now also has both C++ and Python options. You can see the same code in different languages. And with that, I'm going towards the outro. I would like to draw your attention to recent publications. You can find more of them on the whiteboard back there. One major one is a publication of David Schneider talking about the updated RBF mapping. This is a very nice read that should complement older reference publications. Then a publication on ASTE that you used in the course yesterday. This is on the Journal of Open Source Software. And another publication there is also by Asian, you can find behind. A publication that comes from mainly me is about the system regression tests that we are now actively using to run nightly tests and make sure that complete simulations work together. You can also find out more how you can use containers for your application there. And we also have a publication out of mainly a student project on the Nix packages of preCICE. Other news, we do have this Zenodo community that I'm inviting all of you to upload your talks from this workshop, your data that you associate with preCICE. This is one way to make them findable and citable. If you are looking for students or you are looking for a job, please write in the forum. We have a job and thesis announcement board. If you want to just upload your case somewhere instead of Zenodo, you can also do it in our forum. You can tell us something more about how you use preCICE and we can feature it on our website. This is something that you might have heard many times already. And Benjamin is going to talk more about that. If you're writing a new funding proposal and you need to show that you can get active support from us, please consider asking for a support license. Okay, as a summary, many small things here and there, some of them more important than others. A lot of community stepping up. I have skipped here, of course, everything that Frederick mentioned, the standardization that's coming up by Frederick, and a lot on tooling that Felix will talk about tomorrow. So I hope you can make it to the news slide of the next workshop. And if you manage to open a pull request on something during these days, we have a small prize for you. Thank you very much.
Thanks a lot, Marcus. Okay, we could take a few questions. Does anybody have something they want to ask Marcus?
Thank you. It's a question regarding the OpenFOAM adapter and about using nearest projection mapping if we configured it as a volume coupling. Is this going to be supported since we need to set connectivity to true and it's not working with cell sets right now?
Mm-hmm. So the volume coupling in the OpenFOAM adapter, this is something we added last year with limited use cases in mind. If you have such a particular feature missing, please open an issue and we can definitely add it.
Okay, thank you. Cool.
There is one.
Yeah.
I have just one quick question about the lights adapter. Do you know when it will be published, roughly?
I would direct the question to the people next to you.
So as part of Robin's thesis, the dataset is already public, so you can also access the adapter already. I can send you the DOI. I think we're still working on a more polished integration into the preCICE organization, but yeah, I guess this doesn't prevent you from already using it.
Any more questions? If That is not the case. Let's thank Marcus once more.
Thank you very much.